everyone. Today's topic is going to be balancing innovation and responsibility. So the image is crystal clear. We need a way to be able to build governed and moderated GenAI applications for use in the enterprise. So if it is for entertainment, it's for fun, it's a different thing, but enterprises have slightly more stringent restrictions and requirements. So let's look at what that is. Mr. Murthy has already introduced me very nicely. So just again, for context, I'm a lead solutions architect at DataBricks. I've been in the industry for 25 plus years. I teach a graduate course on data engineering at the Harvard Extension School. If you ever consider taking that, it would be wonderful to see you there. And I've authored the book, Simplifying Data Engineering and Analytics with Delta. Now, the agenda for today is what are the opportunities ahead of us, because we are definitely in the hype cycle and everybody, including my mother and grandmother, are using ChatGPT. So it is very, very accessible. Along with it, there are true benefits like productivity and innovation. But like with everything else, these come with some challenges. So let's look at what are the additional challenges that especially enterprises are facing around hallucination, bias, data privacy violation, cost of technology, speed to market, being able to differentiate yourself. If everybody were to use ChatGPT, how would company X differentiate from company Y? And the solution is to be able to use your own data, to use your own models, and responsibly innovate through governance and moderation. They're two similar sounding words, but we are going to see how they differ. I work with DataBricks. So DataBricks is a very innovative data and AI platform. We refer to it as the data intelligence platform. So in this context, I'll explain what agents do. The previous speakers were also talking about agentic framework. And if you look at the internet, it is flooded with them. There's talk about vertical agents. There's talk about how agents can help you augment your LLMs to be able to get more out of your data intelligence. But can they go rogue? Can you tame them? And how can you build these agents on DataBricks? I have a very short demo, time permitting. I'll show it to you. Every enterprise wants to take these things into production. But the reality is everybody is playing with it right now, and there are very few production use cases. And so we'll talk about how can enterprises accelerate this adoption of GenAI for true production use cases. What are some of the capabilities that are necessary to be able to do so? This is a very good study by McKinsey, where they have tried to articulate the value of GenAI, because, are we really past the hype? Can we really think of the kind of scenarios that it's going to help with? When you have a hammer, everything around you begins to look like a nail. No, that's not quite true. Yes, GenAI can replace some of our existing solutions, but it can also create additional value potential well above what can be unlocked by our traditional AI and analytics. And these numbers here kind of prove it, and these are in trillions. So this is like a huge playing field. The excitement is real, but we are still at very early stages at the tip of the iceberg. And pilots are kind of making their way into production across all industries. Nobody's sitting still. It is okay to fail, but learn something from it. But not doing anything would be really, really a big mistake. The full impact and the ramifications are being explored and examined. There are inherent risks. There's people, process, and technology that have to adapt to it. There's new skilling. There's new regulations that will be necessary to be rolled out. And while we are going through all of this, to reap the full benefits of the GenAI for an enterprise, it needs to be done right. So I'm sure all of you have watched Indiana Jones when he was trying to get that little gold nugget, right? If done wrong, it will bring the whole thing down. But if done right, you're going to reap all the benefits. Now, what are some of the things that are your challenges? The responses can't be just cute. They can't be just funny. They have to be almost 100% accurate and relevant all the time. There should not be bias and toxicity. There should be no data privacy violation. It should be useful to the user. Like I can sit and play with it the whole day, but in a corporate environment, it has to provide some ROI. In addition, it should be performant, it should be cost effective, it should provide the market differentiation, and you should be able to develop and deploy quickly. It should not bring any disrepute to the business by saying things which are not professional. This topic is especially pertinent today which is the governance and moderation aspect, because if it is not addressed, we risk losing the ROI on the AI investment and doing more damage to the business. So what are some of the things that we need to care about? Mitigating the ethical risks. So every ML system has got some inherent biases. Now, how far is it going to be stretched in the case of GenAI? Can it harm users, stakeholders, or society? Maintaining compliance and privacy. So GDPR and HIPAA and all these other rules still apply even if you're applying GenAI. So inadvertently, it can't blurt out sensitive information. How can we maintain that trust and avoid legal ramifications? Enhancing trust in the AI output because it is generative in nature. It's either generating text or it's generating images or it's generating video. It's always creating something new, which is why it's not exactly the same. It's not very deterministic. Earlier, when you're creating a number, it's more or less around the same ballpark. But here, each time it could be quite different to be able to even evaluate or measure it accurately. So the transparency, the fairness is important. Otherwise, no enterprise is going to adopt it. It should minimize your operational risks. Things like incorrect predictions, even if it is done for a very small percentage, could bring down your business and your operational stability. Facilitating scalability and collaboration. It's great that you are able to play it with it and show it as a POC. But what about taking into production and being able to handle a lot of requests at the same time? And does it play well with everything else that the enterprise has? What about long-term sustainability? Is it going to be well integrated so that it can continue to grow and thrive? Otherwise, you'll have just one use case out there and it'll still sit there and it'll get stale and then nobody knows what to do with it. So the solution for that is we should think about governance and moderation together. But first, let's figure out what are these two words and why are they different. For governed, the focus is around policies and frameworks. The goal is around compliance and accountability, and the scope is very broad system management. Some of the tools and processes include data lineage, access control, and an example could be sensitive data, restricting access to it. Whereas moderation is about being able to have oversight on the output or the input that is going into the system and at real time so that accuracy, safety, and alignment can be honored. And it's about behavior management. It's about monitoring, filtering, feedback. So you begin to see that, yes, governance and moderation, they are two faces of the same coin. Detecting and correcting biased responses, for instance, would fall under moderation. Now, what does an enterprise need? For enterprises, governance ensures that the foundations of the GenAI application, by application, it means it's the data, it's the model, it's the code, it's all the processes surrounding it, aligns with the legal, ethical, and business standards, while moderation ensures that the outputs generated by the system remain reliable and appropriate even in real time. Both of these things are needed to balance innovation with responsibility. Now, what are all these agents that folks are talking about? Well, let's take an example. Suppose you have a customer come into your store and say, "Can you help me return my last order?" Now, it's a very simple question, but there's a ton of steps to take to ensure that this gets executed. The first thing is, what does last order mean? I need to look up to find out what that last order was. You find the information, you query the policy documents. Is a 30-day return policy, 60-day return policy? What is the reason as to why this was being returned? Is it because I changed my mind or because it does not fit or was it damaged? Then you have to take an action. You have to open up a ticket and you might scan some labels or a QR code and you should give them the shipping label. And then finally, done. Here is what you need to use to initiate your return. So this complex reasoning, which is multi-turn, and it requires some understanding of the domain in which this question was asked, is what agents are all about. And they're very verticalized because returning um, maybe a food item is very different from returning a clothing item, is very different from returning, like, say, a large equipment. And so you would have, and every business will have its own agent. You can't reuse these agents as as readily because the business rules around them is going to vary from enterprise to enterprise. With that, let's introduce the DataBricks Data Intelligence Platform. It's a very broad system in which your data remains in open format. Now, when we're talking about big data, we're talking about petabyte scale data. So it cannot fit in a single computer, and you need distributed compute for it. So the format of the data is Parquet, and it could be Delta, Iceberg, but it does not matter. There is Unity Catalog, which serves as a single governance pane for all your data and AI assets. So it's not just about your files, it's not just about your tables, but it's your models, your dashboards, your vector search indices. Everything is an asset around data and AI and should be governed exactly the same way. The lakehouse is a term that was coined a while back, and it refers to the fact that these platforms can now operate and give you the best characteristics of both a data lake, as well as a warehouse. And that is how the two terms get together, and it's a lakehouse, which is a single unified platform, as opposed to stitching multiple of them. And you can build your use cases on top of it, whether it is AI, BI, SQL, workflow, ETL, everything is done the same way. So once you get your data curated, you don't move it around as much. Now, enterprise data is, these ETL pipelines, just to maintain them, manage them, they take a lot of effort. And your application quality requires that your data quality is high, and so that the insights that you're generating out of them are accurate, safe, and governed. So as we were talking earlier, data is the lifeblood of anything AI, and it's constantly changing. Like, your data in your warehouses and your data lakes and your legacy systems, they are changing. It's not static. If you look at GenAI architectures in general, there are four main ones. Prompt engineering, where you take any LLM, any large language model, and you use prompts to evoke an answer out of it. But these models have been trained at a particular period of time. So if you wanted to understand your enterprise data, then you leverage a vector search on top of it and you convert that into a RAG architecture. Now, if you're not fully happy with the results, maybe you'll fine-tune the model, or maybe you'll pre-train from scratch. Although this is rare, this is becoming more and more prevalent. Long story short, models always go stale. Even a model that was created a minute back is going to get stale. So LLM models are expensive and time-consuming to create. RAG is a strategy that works for some extent because the documents can help give answers to your enterprise questions. But there might be real-time data that needs to be augmented. And that is where agents come in. They are basically tools that can look up databases, reach out via REST APIs, coordinate amongst themselves, and deliver important responses to the user's intent. Here, context is king. Instead of a very large monolithic model, like say ChatGPT, where it's general intelligence, you're giving it a variety of questions, and it's going to give you answers which are very similar. If you ask versus I ask, you'll get about the same. But the future is more about nimble, task-specific agents that can reason and are coordinated by LLMs. So this is an example of how you have these data sources, and these are your pipelines, and you constantly refine this data. Your business has got some workflows, and these are different kinds of agent libraries, all trained at very task-specific things, but they can also interact with one another, kind of multi-agent architecture, to be able to get your users the response that they are looking for. They reason over your data. So, you can have models, you can have tools and functions, you can have chains. That's the topmost level. They are looking at data, and some of this data is structured and some of them is unstructured. Some of them are just features. And then at the bottom, you've got all these orchestration that we were seeing in the previous slide. You're going to leverage these tools and functions to give you the correct answers. Otherwise, there'll be a lot of hallucination. You can automatically generate vector search indices on all your unstructured data, like policy documents and all. But there are lots of structured data too. So this is a wonderful combination of bringing it all together so that you get more holistic view of your data. And you need to be able to build and use these agent components quickly. as part of models, as part of functions, as part of chains. This is not enough. Again, how do you know that it is at a right point to be pushed into production? Somebody would going to create another model tomorrow, another model the next day, because models are becoming pretty ephemeral. Something which is on the leaderboard today is going to be replaced by something else, and you're not going to spend all your time just updating your models. Once you know that you are ready with a certain use case, you have to release it into production. How do you know when you're ready? You have to have an evaluation data set, and you need different ways to be able to evaluate. In terms of what kind of model you want to use, there are open source models, there are commercial models, there are custom models. So you should be able to use any model because that decision is yours. Then you want to evaluate the agent system. So for that, you need some ground truth. You might have synthetic data generation. You could have SMEs to label your data, or you might have some rudimentary data with which you can get started. Now, there are LLM judges and there are human grading apps. So all of this has to work together to continuously refine it. Otherwise, you've reached a certain peak and that's it. You're going to stay there. You'll never be able to go to the next level. So to be able to automatically measure the output quality at scale with these AI-assisted judges and augmented with human judges is pretty important. To be able to trace root cause of quality issues, because now imagine these agents are not very different from the software components that we have been developing for ages, right? Instead of one large hunking model, we now have a compound system which is broken up into these agents. And when there's a problem, you need some tracing to be able to understand where the issue is coming from. You can't just rebuild the whole thing over and over if the problem is just in one specific thing. The governance is needed for your data as well as your models, which is where Unity Catalog comes in. You go there for your discovery, like what data sets exist, what models you can reuse. You go there for sharing of data. You don't have to bring in another ETL pipeline because those are expensive. Access control, who can do what with the data. Auditing, I accessed it, but I was not supposed to. That was audited so that something can happen to it. Lineage, how good is this data? Where did it come from? How many transformations was done on it? And monitoring. I had 5 million rows coming in yesterday, but today I got only 1,000 rows. Isn't there something wrong with my pipeline? Or my accuracy has just jumped and I do not know why. It's a good thing, but not knowing why it was happening means that tomorrow I will not be able to replicate it. So all of these things come under the umbrella of governance. Now let's look at a 5,000-foot view. You have the data platform, which is where you have structured and unstructured data. The governance is not for just a small piece of your estate. It has to be the full estate, which is why it's a big block that you see. And that is what we refer to as Unity Catalog. And you have the model registry also. I'll show that to you in just a second. On top of that, you have your serving layers, and this is your typical preparation of your data, evaluation of your data, and then serving of your data. Even as you are preparing and evaluating the data, all of those logs are super important, and the component called MLflow kind of comes to your rescue. For serving, you have things like AI Gateway, Lakehouse Monitoring, and Lakehouse Apps, which are designed for the enterprise so that you don't have to build it 5 times over. Right from the beginning, it is keeping in mind the security and governance controls. And this is how it all comes together. You have your data preparation, as we talked about. Some of it is synthetically generated, some of it is from the field, some of it is labeled by SMEs. Then you build your agents, and you could use different LLMs for different agents. Maybe one agent is just doing a database lookup, another one is using a REST API, another one is using some classical ML models, and so on. Then you deploy it. The minute you deploy it, your lineage was going to start, and you should be very careful. I have a little chart here which says that the greens are mostly the governance ones, and the orange are the moderated ones. So when you evaluate, there's more of the LLM judges and the peer labeling and the tracing in the orange skin. And then the governance is around AI guardrails. So as a user, I may inadvertently give some crucial information which is sensitive. So the guardrails will kind of stop that information from going into the LLM. Similarly, the response of the LLM is also going to have another guardrail. So if something is leaked out there, then the guardrail is going to catch it. So this is very important, especially in the context of GenAI. The usage tracking. the credentialing, the rate limiting, these are all governance tools. Now, you might say, let's take a step back and make a broader sweep as to in the enterprise, these are data-related problems, model-related problems. But what about all the deep fakes that are happening, all the bad data that we might be buying from somewhere, or how are we going to address it? Because that's a big problem. Now, AI systems with built-in constraints to prevent misuse, such as using watermarking of AI-generated content or embedding of provenance metadata, these are techniques that are just about hitting the the surface, and people are beginning to think about it. Imagine somebody takes a picture of me and is able to feed it with lip sync, and somehow I'm starting to mouth words, and some of my friends might see it and say, oh my goodness, how can she say such a thing? But that's not me saying it. That's a deep fake saying it. And this is a real problem. It's just become so much easier with GenAI. There are regulations in the horizon. For instance, there is the EU AI Act, where it's not completely in motion, but it's going to classify AI systems by risk levels. And this is important. What is high risk? What is minimal risk? What is unacceptable risk? So that I, as a consumer of it, will make the judicious decision as to whether I want to use it or I don't want my data going there. And they're going to mandate specific compliance measures such as transparency or high risk system. In the United States, it's less comprehensive, but it's beginning to happen. There's the NIST AI management framework. And if you are using algorithm to decide whether somebody gets a loan or doesn't get a loan, then you'll have to give a report on how it functions. So that's the algorithmic accountability. I just took an example, but it's going to be even more serious. And then global efforts, like these are countries that are at the forefront of pushing for policies that are necessary to protect IP, data use, and transparency in the AI system. We are still not quite out in the woods yet. These are still being decided and debated, but at least people are thinking about it, because the ramifications of not doing these things are pretty huge. With that, let me see if I have time for a demo. I think I have a few minutes, so let me switch out and show you a little bit of the DataBricks platform. When you land on the portal, this is what it looks like. You have the SQL persona, this is the data engineering persona, and this is the ML persona. And Unity Catalog, which is like almost the nerve center of the data and AI platform, looks something like this. So you've got a catalog. In it, you've got your schema, just like any other database. But then you're going to, let me actually look for something. So here, for instance, within the schema, I've got tables, which is all right. Everybody has that. But we have volumes where you can put unstructured data, like your images, your videos, your text data, and it comes under the same governance. You can have models which are governed. You can have indices, and you can have dashboards, and everything else comes under, you see, one pane of governance. Now, what can you do with it? Of course, you can see your metadata. You can see sample data. You can see where it was created, where it is pointing. But more importantly, you can go to the permissions tab. Let's actually go here. And in the permissions tab, you will see who can have what access to it. Some may have select privileges, some others may have write privileges. You can see how data has come in, what is the history of it, what is the lineage of this data, not just from a table perspective, but how the workflows have changed, how the pipelines have changed, how the queries, the models, everything down to the column level. Only then can I trust the data and its provenance to be able to use it. Insights is, who are the people who are using this data? So today, if I decide to stop that data set for whatever reason, these are my downstream affected people. So these are the dashboards, the notebooks, and other users who are using it. Then there is quality. So this is the lakehouse monitoring aspect that I was talking about. Profile metrics and drift metrics are automatically being gathered. Now, I had an underwriting data set that I created for you about a client coming in with a submission. There's some risk data, there's some actuarial premium calculations, there's some code system. And this is the DataBricks playground in which I fitted in some of my functions, and then I asked a question, explain the quote for blah blah company using its risk scores as to what kind of a quote should I give it. So this is an underwriter coming and doing what if analysis. So it first gets the scores. You see, I didn't tell it to use these functions. It just knows that it has to first get the risk scores, then get the quote, and then look at all the risk scores and the quotes to be able to make a distinction as to why should my premium be this, what is my coverage, all of that wonderful stuff. And there is an AI judge which is constantly evaluating the response and say that, yes, this is safe and this is relevant. So a lot has been packed into here. I can always export this, take it and put it on a model serving endpoint. The last thing I want to leave you with is the AI gateway. So as your data is coming in, you want to know what your users are asking, what the payload request was, what the response was, who are your heavy users, which models are being used more, is there any PII information that is coming into the system, and who are the people who are concerned about data quality, and how has that changed over time. All of that can happen once. So every time you build a model and you're building an agent, you don't have to think about this. This is almost like scaffolding code that goes along with the model. I know I'm at time, so I better stop here and see if there are any questions for me.